Okay, the last thing we need to talk about for Chapter 3 are your lab techniques, the different ways to separate mixtures. Okay, and each method has a different way of separating mixtures. So the first method is known as distillation, and distillation uses the property of vapor pressure. And what vapor pressure is, remember, I'm not saying gas pressure, I'm saying vapor pressure. So the difference between a gas and a vapor is this. A gas we already defined as a single specific state of matter. A vapor is a gaseous state of an element. So what's going to happen is you will have a mixture of alcohol and water, and you will heat the alcohol and water, and each one of those has a different boiling point, and each will turn to a vapor. But they will turn to a vapor at different boiling points, and from that property, you can separate one from the other. So the alcohol will actually vaporize first, and that will become separated. You can condense it, collect it in a different test tube, and the water will remain in the other test tube. And usually this is used to purify mixtures. You can actually do this with salt and water, but we're going to do this with alcohol and water. So if you look here, this is basically the setup. Ours will be a little bit different. We'll have a hot plate, we'll have a very basic condensation tube, and we'll also have some ice over here. So you'll basically have a hot water bath with one test tube full of alcohol and water. You will increase the temperature, causing the alcohol to turn to a vapor, travel down the condensation tube, and collect in an ice bath in a separate test tube. So this is based on evaporation or boiling because different liquids vaporize at different temperatures. So you will attempt this technique in the lab. Filtration uses size to separate mixtures, and you will also be working with this in a very detailed lab. You basically use filtration to separate, let's just say, sand and water. If you had that in a beaker, you would pour that into a funnel with filter paper folded correctly, so be careful how you fold your paper, otherwise it'll all pass through. The idea is that the water will pass through and the larger particles of sand would stay on top. So filtration is based on size. And you can see the funnel here, there's paper on the inside, and you usually collect it in a beaker underneath. Decantation or centrifugation, we're not going to use this technique, but it's basically based on density. If you know what decantation is, it's basically pouring water off and letting the heavier particles stay on the bottom. But a centrifuge is an actual machine that can separate blood, for example. You put it into a vial and seal it, and then it kind of spins it to separate out the different parts of blood, like fat and so forth. Another method that you will use is chromatography, and this is based on solubility. So you'll actually be separating different food dyes, and as you can see in this picture here, different colors travel up the chromatography paper at different rates, and you'll be able to measure that. So they're basically dissolving on the paper and then traveling up by capillary action. So this is a technique you will try. All right, and we end the chapter just with a brief statement about energy. Energy is so important that we will actually have this as a separate unit to look into more detail. But just as a little preface here, energy does have an effect on matter. There are different types that you should be familiar with: solar, nuclear, heat, and wind. And we define it as the capacity to do work. And right now you're probably just comfortable with heat energy. For instance, if we collect the alcohol from our distillation lab, you can actually burn the alcohol and release some energy. When water is heated, right, you saw my pictures earlier, molecules vibrate from the added energy or heat that was added, and you see that in the form of bubbles. So energy is all around us, has a significant impact on matter, and we will talk about that in a later chapter.